Hello. In this section, we are going to talk about the concept of polar coordinates. So last time we had parametric equations and that we can write our typical XY coordinates in some other ways. This is, again, another way we can write XY coordinates. So suppose I have some point on my coordinate plane that is in X and Y. And this is known as Cartesian coordinates or rectangular coordinates. We know that the point XY is referring to the distance on the X-axis on X out in some direction and Y up in another. And that's how we have named off the rectangular coordinates. Polar coordinates, or circular coordinates, take the idea of the circle and say, this point here is some radius distance from the origin. There is some distance here, r, and then there is some angle, theta. And we can use that radius and that angle to name off the same coordinate. And this is known as polar coordinates. So this is another coordinate system to be able to plot points and get some unique curves that we haven't been able to work with before when we're working in Cartesian and rectangular. So taking a look at plotting some of these points, these are all talking about a radius and an angle. So the first one, radius 0, angle, whatever we want to put there. We could put any number there as the angle. If the radius is 0, we have not gone anywhere from the origin. So the origin is the point 0, any angle, which we call the pole in polar coordinates. So instead of calling it the origin, this is known as the pole. The point 4, 3 pi over 4 is we are going to go out a radius of 4, 2, 3, 4. So we're going to be somewhere on this fourth circle. And then the angle 3 pi over 4 is saying we have an angle of 3 pi over 4 off the x-axis. So ultimately, the point 4, 3 pi over 4 is approximately here. What if we add in negatives? Well, if we add in a negative, saying negative pi over 6 means we go clockwise pi over 6 off of that axis. So 3, again, we're on that third radius circle. And going negative pi over 6 means we go counter or go clockwise pi over 6. And then if we have a negative radius, that does still mean we are on the second circle, but instead we're going to go our angle, so pi over 3. This point here would be the point 2, pi over 3. And so -2 comma pi over 3. I am on the wrong circle. I'm on the third circle. The second circle is here. This would be 2 comma pi over 3. -2 means we're going to, instead of going that +2 distance away from the origin, we're going to go backwards and go -2. So there is the point, -2 comma pi over 3. Now, you might note the fact that there's other ways to talk about these angles, and absolutely there are. So focusing on this 3 comma negative pi over 6, I'm going to look at some other ways we could write that. We could also write this as 3 comma 11 pi over 6, because we know if I add 2 pi and go around the circle again, I'd land back at the same angle. I could write it as 3 comma 23 pi over 6. It could be 3 comma negative 13 pi over 6. There's a lot of ways to write that angle because I can add or subtract 2 pi. The other thing to note is I could, instead of having that positive radius, I could have a negative radius, -3, and instead find the angle that gives me this point here in black, which is the angle 5 pi over 6. Or the point -3 comma 17 pi over 6. All of these refer to the exact same point, because the point r theta is going to be equal to the point r comma theta plus 2 pi. So any multiple of 2 pi, those are going to be the same. And the point r theta is also equal to the point -r comma theta plus pi. So all of these are equal to each other. So I can add 2 pi and keep the radius the same, or I can add pi and make a negative radius, and all those points refer to the same thing. So there's many ways we can write polar coordinates. So that gives us our note that says polar coordinates do not give a unique representation. When we talked about when we had XY coordinates, if I said the point 2, 3, there was only one way to write that point 2, 3. And it only gave us that one point. Coordinates, I have listed off 6 different ways to write the same point. So the way to write the point is not the only way to write the point in polar coordinates. So there are many ways to write the point r theta. And in the next video, we will take a look at switching between Cartesian and polar coordinates.